Number 4 on the review has the customers of a pet store, and it's talking about 40% of the people have a fish tank. So what circle is that, red or blue, or is it just a portion of one? When they say the probability that a randomly selected person has a fish tank is 0.4. Is that the whole red circle?
No. Actually, no, yeah, it is. It's like a
That's the whole red circle is worth 0.4. Okay? The whole red circle is 0.4. Probability that they have both is what? 0.1. Okay, the probability they have both is 0.1. The probability they have neither is 0.25. That goes out there. So how do we figure out the part that has red but not blue? Fish but not bird. 0.4 minus 0.1 is 0.3, period. Okay? 0.3. So what should 0.3 plus 0.1 plus 0.25 plus this missing number all add up to? 1. So what's remaining for the box is 0.35. That's called a probability Venn diagram because it has the probabilities, not the number of people that have each type of pet. To get the number of people, you take each of these underlined numbers times the total customers, which is what, 400? And you get how many people have a fish only? Both? Bird only? Neither. 100. They have something else, right? A quarter of 400. So those are all the answers to the Venn diagram and how they all go in there. Next, what's the probability that they have a bird? What section is that? What color is that? Total blue? They have a bird. If you have both, do you have a bird? Yes. So you have to add 0.1 and 0.35 to get 0.45, 45%. What's the probability they have a fish only? 0.3. You do not want to include the people in the blue circle. How many customers have both? 40. You go to the frequency diagram and you use 40. And finally, how many have a bird only? 140. That's the blue but not red. Those are all the correct answers to number 4. My follow-up question was, are these two events, person has a bird, person has a fish, independent or dependent? And the answer is dependent. In the one example with the two students applying for a job, what's the probability of success or failure? And that was number 2, John and Sam. The probability of Sam getting the job didn't change based on whether John succeeded or failed. So they were independent. Here, we're going to approach this a different way. To see if fish and bird are independent, the probability of owning a fish, which is what? What's the probability of being in the red circle at all? 0.4. Needs to be the same as the probability of F given B. Now, let's talk about how to calculate that. To find the probability of F given B, we need to check to see if the probability of both divided by the probability of bird alone. Probability of both is right here. It's 0.1. The probability of bird is 0.45. That comes out to be 0.222, repeating. So if this number is different from this number, the two events are dependent.